We're going to get started here just in a minute. Hello, everyone. Hope we all had a fabulous spring break. I'm going to hope that everything is loading perfectly, which it appears it might not be, so hopefully as we get going it will correct itself. I do suggest today that you work with me and draw these as we go so that you can kind of get a feel for what we're doing. We're going to look at this in a couple different ways, so I want to make sure that you're following along as we go. So the first thing that I would like everybody to do is I would like you to draw a right triangle. And it looks pretty generic, always facing the same direction, the right angle there. We're going to name this one X, Y, Z. And the first thing that I want us to take a look at is that we've done a lot with the Pythagorean theorem. And with our Pythagorean theorem, we know that the two sides where the right angle touches, the two sides where that tick mark touches, are called the legs. So that's the first thing that I want us to take a look at. So the two segments that meet at the right angle, those are our legs, and the side opposite our right angle is the hypotenuse. The hypotenuse is the longest side. The legs of our right triangle could be different lengths. One longer, one shorter, doesn't matter. Or they could be the same. But the longest side is always the hypotenuse, and we looked at that when we did our Pythagorean theorem information throughout the year. So that's just something to keep in mind. The next thing that I want you to do then is we're going to draw this again underneath here. And this time, we're going to go ahead and we're going to label it again X, Y, Z. We're going to put our right angle in there. This time, we're going to take a segment from Y to the hypotenuse, and we're going to make a right angle. That's going to create this other point. We're going to go ahead and call that W. Now, this segment that's drawn from the vertex to the opposite side and is perpendicular to this side is called our altitude. So this guy right here, we're going to call our altitude. All right, so in review, I want you to remember the definition of altitude. So remember that an altitude is a segment from the vertex of a triangle and is perpendicular to the opposite side. And that's what we have there, perpendicular to the opposite side. All right. Now what that does is it takes our hypotenuse and it breaks it up into these two little pieces. We've got a segment WZ and we have a segment WX. So we actually now have XY, ZY, WY. Those are all segments. We have XW, ZW, and all the way across is XZ. So we have quite a few segments going on in here, but I want to make sure that we remember that our altitude is that segment from a vertex to the opposite side, and it's perpendicular to the opposite side, so that's why we see that right angle. All right, so we started off with this original right triangle. We then took that right triangle and we threw this altitude in here. And now what I can see is I have two new triangles. So we're going to do this again. All right, so I'm taking this in steps right now, just to kind of go through this and remember what we've been talking about. So we talked about at the beginning of the year all of our information about right triangles, leg, hypotenuse. We even talked about the Pythagorean theorem. We then got to a chapter where we talked about segments in triangles, and we knew that this guy was called an altitude. So then what we're going to do is we're going to start again, and now we're going to look for three similar right triangles in this picture. So I said we are going to do this in steps, and Miss J is correct. If any of you guys aren't looking at the chat, she is reminding you that we've already talked about altitudes because we used them in our triangles, but we also used them to find the orthocenter of our triangle. So we're going to start our triangle again. We have our right angle. We have X, Y, Z, and we're going to go ahead and we're going to draw in that altitude and W. So now this is what it looks like without all the other stuff written on it. And what we want to look at is that I do actually have two triangles sitting in here. We've got our other right angle that's on this side. So we had our initial right triangle, and then we have these two other little guys. Now I am going to color code these just to make it a little bit easier to look at. And we're going to start with this big right triangle here. And I'm going to name this guy in green. And I'm going to draw him right here. And obviously it's not to scale. It's not going to match perfectly because I'm hand drawing it. But that's that first right triangle. Then what I'm going to do is I'm going to draw this right triangle. And notice that I'm using X and Y again, but now I have to incorporate that W. So that guy is going to look like this, this, and this. So here's our W, here's X, and here's Y. And last, what we're going to draw is this guy. We have Y and Z again, and now we have to use W again. So over here, I'm just going to, again, it's not going to be to scale, because it's all hand drawn, but you can kind of see that I separated them in the same direction, orientation, but definitely the color. All right. So here's what we want to look at. In common in each of these right now is our right angles. We had our original right triangle with the right angle, and then our altitude, when it was drawn in, created those two right angles. So right now, all three of these triangles, the largest one, and then these two smaller ones that fit inside here, again, not drawn to scale, but they fit inside here, they all have that one thing in common so far. So when we talk about why these are similar, these are actually similar by angle. And we just saw that it's because we have a right angle in common. Oops. But that's just one. We need two in order to do angle. So then I want you to look really close, and I'm going to zoom in here for a second. You can see that right here at Z, Z's angle, this whole angle is part of the green triangle, but that whole angle is also a part of the orange. What do we call that when an angle is repeated, or a segment for that matter, but in this case an angle? The entire angle is the same, and the entire measure is the same. So it corresponds. They are the same measure. They're in the same position. You can see up here it happens again. The blue triangle and the green triangle share that same angle there. So what do we call it when it's the same angle, when it's the same measure, and it's in the same position? What do we call that when they're going to be the same? They just happen to be in two different triangles. What property do we call that? What property do we call it when we see that those angles are the same? All right, as I wait to see if we're putting anything in the chat column, I'm going to zoom back out. Anybody know what that's called? All right, those are actually reflexive angles. We know that it's the same measure in the same position, in the same spot, using the same value. So those are actually called reflexive angles. So we have right here at angle Z, we have this one has a certain measure, but wherever I see angle Z, that's got to be the same measure. And when I look up here at angle X, I know this guy's reflexive because it's used in the blue and in the green. So wherever I see angle X, I now know that guy has to get that measure. Well, that means if I have a right angle and I already have this blue tick mark and I got a right angle here and it matches this blue tick mark, the only other measure it could possibly be is that orange tick mark because the triangle is supposed to add up to 180 degrees. So I know this guy here has to be the same measure, and I know this guy over here has to be the same measure. And if I'm unsure, I can always throw in an extra value or an arbitrary number just to kind of help. So let's say I thought this guy up here was 20 degrees. Okay, just 20 degrees. that means he's 20 degrees here and 20 degrees here. Well, if a triangle is supposed to add up to 180 degrees, and I already have 90, that means these two have to add up to 90. Well, 20 minus 90 makes this one 70. I know that because that's how triangles add up to 180. 90 plus 20 plus 70, that's going to be 180 degrees. Well, over here, if this guy is 20 and this guy is 90, and I add it up to 180 degrees, I don't have a choice. This guy has to be 70. So whether I look at it as the tick marks or I actually try the numbers, I can see it's always going to be that. Well, again, if I knew that this was 20 and this was 70, that means this guy's got to be 70. That was our reflexive angle. Well, if I subtract from 180, there's no way around it. This guy is going to be 20 degrees. So the point is that whatever our original right triangle has as angles, these other two share those exact same angles. And our reflexive will always be in the same position, and the other acute angle will always appear. I'm going to say that again very carefully. The reflexive angles will always get repeated. The other acute angles will always appear. And that way all three triangles have the exact same numbers. Now I'm using these tick marks or these angle numbers to help me then find my pattern. Because remember, if they're similar by angle, and I've got to name them using the same pattern, looking at a pattern is a lot easier than trying to look at my diagram. So I have X, Y, Z. Instead of looking at X, Y, Z and trying to figure out how do I name these, I'm going to look at 20, 90, 70. 20, 90, 70. X, Y, Z, 20, 90, 70. Or I could say blue, green, orange. Or blue, right, orange. So over here, blue, right, orange. So if I was to name this one in the same pattern, 20, 90, 70, or blue, right, orange, I don't have to worry about the letters. So X, blue, right, orange, W, Y, 20, 90, 70, 20, 90, 70. Because this one went 20, 90, 70, and this one went 20, 90, 70, this one has to go 20, 90, 70, or blue, right, orange. So that means this one has to be Y, W, Z. Now, part of what you're going to see in your homework is just this. Plug in the values or the letters in the correct order. So patterns and drawing these out and putting tick marks or color coding on scrap paper is going to help tremendously. Now, notice, and I'm going to put this on here just so that it's another double check. Your right angles are always in the same position. They should be in the middle, but at least we know that they're always going to be in the same position because they must correspond. And again, we've talked about correspond for months. So our right angles were always in the same position. I want you to also take note that when we talked about our reflexive angle, this one was reflexive to this one. We again know reflexive means that they're the same measure. And we can see that this one is our reflexive angle. And those are in the same spot. So at that point, the only thing left to do is place that other acute angle in the other position. So if X was first, X has to be first here. Wherever the right angles were, they have to be in the same position, whether it's in this case second, and our other triangle has to have the other reflexive in the same spot. So these are just different ways to make sure that our triangles are associated in their name, this similarity statement, the way it's supposed to be. So we're going to do this one more time. We're going to do this one more time with a different picture. I said we're taking this in steps so that we get a good feel for this. So we are going to complete the similarity statement. I'm going to change the picture, and then I'm going to create my dog, and I'm going to change the letters. And we're going to name our first triangle ACD. And I say this first triangle because I could have named it I could have picked any of the three, but there's my first triangle. And I want to see if you're able to answer any of it, given the strategies that we were using. Now, as you're trying to guess how the pattern works, again, maybe what we do is we color code what these look like. And we can, I'll stick with the green for the large triangle. Again, as you think you know, type in the first answer. If you think you know what the first triangle is, or the second one, because obviously there's no order, doesn't really matter which one you name first or second. But if I have the first one, we did like this. So here's D, C, A looks like that. Another triangle we can do here in pink. And we have A, D, and B. And we have another one. I'll look up in a minute. I can see my screen scrolling. And we have B, C, D, up to here. Here's B, C, and D. All right, so I see a couple of them getting plugged in. Let's see if we're correct, because again, we're looking to see how these match. So I have my colors, and we can see where the right angle is. So I guess the first thing to do is figure out, where does that right angle go? If D is the right angle of the green one, and that's ACD, that's this first one we named. I want to make sure wherever I put the right angle, I got to make sure it's in the same spot. We also have to keep in mind that we have reflexive angles. So maybe to make it a little easier on myself, again, let's see if you can keep putting your guesses in the chat, and I'll keep adding hints as we go. We can see that our reflexive angle will appear in the same spot. We can see A's should be the same. And if I have my reflexive angle up here at C, That's this guy right here. He should also be here. So again, as you think you got the idea, I filled in our right angles, I filled in our reflexive angles, and all that's left is to fill in the missing piece for these two, which means whichever tick mark's missing, that's the one I plug in. So that means this D gets the double blue, and this D gets the barred pink. So now I just have to match the tick marks. Pink, blue, right. Pink, blue, right. So that was my pattern. So let's see, when I fill in this pink one, I want pink, blue, right. So pink, blue, right. And we're close. We want to be careful not to just match letters. We have to match angles. And again, the angles are going to adjust. So again, pink, blue, right, A, C, D, pink, blue, right. We want pink, blue, right. Now, I'm not saying that was named appropriately. I just want to make sure that we can plug in and follow the correspondence. So that's that one. Let's check to see if the other one, I see that we have DCAs, we've got DCBs. So let's take a look at this one. Pink, blue, right. So Miss Morgan, you did get the blue one correct. Pink, blue, right. Pink, blue, right. Pink, blue, right. So you are correct. Pink, blue, right. So we wanted to make sure that we looked at this one and used our pattern to help. So that's what each of these is telling us. Now again, this does obviously carry in from our last chapter. So that's something that I want to take a look at. All right. So one of the things that we did in our last chapter is, and I'm going to keep using this paper, is we looked at each of these and we had our similarity statement. And from our similarity statement, we were able to write proportions. Now again, I'm taking this, I'm going to take this guy, A, C, D, A, D, B, and D, C, B. And we know that we can't do proportions with 3 equal signs. So what we're going to do is, using this information, we've got our first triangle, we have our second triangle, and we have our third triangle. And I want to create, just so that we can kind of see what's happening here, with similar triangles, we are able to, with our first triangle, angle ACD, if we said he was similar to triangle ADB, we were able to write a proportionality statement. We were able to say that AC would correspond with AD because they were the first 2 letters. And we could say CD would correspond with DB because those were the next 2 letters. And we were able to say that AD, the first and last, would correspond with AB. Now notice, across from each other, you can see that AD gets repeated. In one triangle, it's a certain segment. In another triangle, it's a completely different part, but it's the same side. It's AD. In one triangle, it's the leg of the right triangle. In the other triangle, it's the hypotenuse. Same segment. You can see it up here. It's the same segment, it's the same length, but they do not correspond. They're not even in the same fraction. They're never going to correspond because they're not in the same fraction. So if I just brought those guys together, kind of took him out of the proportion, the equation, what we end up with is this guy, AC over AD, AD over AB. When these guys cross multiply, they're the same. They're going to end up being something squared. So notice that it's this repeated segment down here. It's that leg that we talked about at the very beginning of all of this. That's the original leg of this big right triangle. So that's important. Just following patterns now. We're going to take a look at the second pair. What if we did triangle ADB is similar to triangle DCB? Well, same pattern. Let's go in the same thing. We have AD is the first two letters, DC, first two letters, DB, second two, CB, second two, and then AB, first and last, DB, first and last. Again, right now, I am doing nothing but a little bit of review from the last chapter and showing how it's going to incorporate here. Do we see any letters duplicated? Okay, any letters duplicated? All right, nobody? I see B. Good. Now, what segments do I see duplicated? Do I see anything else duplicated? Any segments? Over here, we saw AD was duplicated. Do we see any segments duplicated? I suppose that was my fault. I should have said it that way. Any segments? We saw AD was duplicated. Do we see anything else in this one that has that same feel? Yep, DB. So because, again, we can't solve a proportion with 3, just like we haven't all year, we're going to take these guys. We have DB over CB, AB over DB, and what we're going to go back is we're going to take a look. And right here, that's that altitude that was inside our right triangle. And this altitude happens to be probably the shortest side of one triangle and the longest side of the other when you're looking at the legs. Here's the shortest leg, here's the longest leg. They just don't correspond. Same segment, same length, but they do not correspond. They're not in the same proportion. But when we would cross multiply, you end up with anything times itself is going to be something squared. So you can see I've already kind of set this guy up over here. We're going to do the same thing one last time. AC is going to correspond with DC, CD is going to correspond with CB, and AD, first last, is going to correspond with DB. Again, I'm not even looking at the triangle, I'm just looking at what we've already accomplished by doing all that hard work. So the same question I'm going to ask, if I look in here, do you see any segments that have been repeated? And again, segments could be named AB or BA. I could name a segment XY or YX. It's the same segment. So do you see any segments repeated in here the same way we had repeated here and the same way we had repeated there? I'm getting my highlighter out while I wait to see if you guys have found the repeated segment. There is one. Yep, you are correct. DC and CD, they are the exact same segment. We've just listed them a little differently. So these guys, when we bring them together, we end up with AC over DC and CD over CB. So what we have in these proportions are these repeated segments. So let's just go back and figure out where CD was. Well, it's the leg. It's the leg of this original green biggest right triangle, but it's the hypotenuse in this small one. What you're going to find is it's the same thing that we talked about at the very beginning down here. Look what AD was. AD was the leg of the original right triangle, but it was the hypotenuse in this one. So what we did down here was determine that the leg is repeated as the hypotenuse in the other smaller triangle. So what we end up with is these patterns where we're talking about the legs and the altitude, BD being the altitude. So notice what one letter is in common in each of these segments that we now decided get repeated down here. AD was our repeated, DB was our repeated, and over here, DC was our repeated segment. It's the same segment in these two. It's the same segment in these two. What's the one letter that's the same? You are absolutely right. The one letter that's the same is that letter D. And what was so important at the very, very beginning about that letter D? What was that? Was so important about that letter D? All right, that letter D was the original right angle when we drew our picture. It was the original right angle, and that's going to be huge because we're going to be able to identify what these are in every one of these pictures by locating that original large triangle's right angle. So what you'll see me doing here is I'm actually writing what all this means now. AD is what's called the geometric mean of those two segments, AC and AB. We're going to define what a geometric mean is here in a second. So that means over here, DB is the geometric mean of CB and AB. And over here, CD or DC is the geometric mean of AC and CB. So it's a lot. I know it's a lot, and you're still like, what does this have to do with anything? We're just talking right now about, do we remember how to put together our similar right triangles, our similar triangles from the last chapter? Do we remember how to write our proportionality statements? And the only additional thing we're really looking at here is, do we recognize where there were duplicates? And this new word, geometric mean. So we're going to finish today by defining a geometric mean. We're going to finish by defining what a geometric mean is. So we did all that work to figure out where is a geometric mean. So a geometric mean is a segment. It is not. So it is a segment, which does mean it's a length. Repeated in two similar right triangles. They are in the same position. They share the same length. So all of this sounds very much like reflexive. That's the difference. So there's segments that are repeated in two similar right triangles. There's segments that are in the same position. They share the same length. But these segments do not correspond. Again, I'm going to come back to this picture very briefly. AD in this and AD in this, they are in the same position. They have the same length. They are shared sides because it's in this triangle and in this triangle at the same time, but they do not correspond. In this triangle, it's a leg, but in this triangle, it's the hypotenuse. And we know that the hypotenuse is the longest side of the triangle. A leg is not. So all last chapter, we talked about matching shortest to shortest, longest to longest, middle to middle. We're not doing that here. These do not correspond. So it is very much like reflexive, but they do not correspond. Very much like reflexive, but they do not correspond. So as I finish this up, you do not have, right now, we are nowhere near finished with this section, but that's enough for today. I want you to practice. You're going to see that in Google Classroom, I am going to load some extra notes for reference so that you have more than enough to look to so you don't have to search the internet yourself. Some I've searched the internet for you. Some I've done myself. And then you will also see that I will load for the week, starting today, your assignment. Please take note that it is due by Sunday, by midnight. But I'm going to give everything to you today so that you can kind of get a jump start. But for right now, we are not finished with this section. I just want to make sure that you are aware that I am going to load everything today. So it's very much like the reflexive property, but different because they do not correspond, but reflexives do. All right, so I'll leave you with this picture. Here's our original right angle. I'm going to name this triangle MNO. So there's our original right angle. I'm going to put our altitude in here. P. And if I'm going to name the original triangle MNO, see if you can fill in the appropriate answers. And then you can check my notes in Google Classroom to see if you are correct. And for today, that's it. We are going to look at where this is used on Wednesday, so make sure that you guys join us on Wednesday, and please make sure that you check Google Classroom. You will find that your first assignment is just this. Can you fill in appropriately the triangle names using our tricks? And don't worry, Mr. Webb, you know that you can go to the classroom or the channel and you can re-watch. Just thank you for letting us know. I will talk to you guys all on Wednesday. Please tune in. Thank you so much for those of you that show up daily to at least make me think I'm talking to somebody. I truly appreciate it. Have a great day, everyone.